Hello, I'm Daniel, and I'm a software engineer here at Terra. In this tutorial, I'm going to help you integrate Terra into your existing or non-existing tech solutions by giving an introduction to our products and by developing an app live on video that relies on Terra. By the end of this, you should have the skills to unlock the power of your users' health data. This tutorial will be split up into three main parts. Chapter 1, setting up your backend. Chapter 2, using the unified API. And Chapter 3, using the mobile SDK. The goal of the live coding demonstration will be to retrieve sleep data and heart rate data. And since Fitbit and Apple Health are respectively the leading industry standards for these metrics, we're going to be using those two providers to power our app. With that all being said, let's jump into the first and most important step. Let's set up the dashboard. Once you first pay for Terra, this will be the first page that you see. The amazing thing about the dashboard is it explains to you exactly how to set up your Terra integration with very few words. As you can see here on the left hand side, we have the first stage of the flow, which would be the sources. And as the name suggests, this essentially allows you to configure exactly where you want to get data from. Now, for the purposes of this tutorial, I'm going to go ahead and add Fitbit since we want to get Fitbit data on our app. And so to do this, we can go ahead and click on the Add Sources button. As you can see, once I've clicked on the Add Sources button, we have a bunch of integrations to pick from and see. The integrations are ranked in popularity, and so as you can see, Fitbit ranks quite highly and appears third on the list. Now, to add Fitbit to my dashboard configuration, I can go ahead and click on Fitbit anywhere and click on Save. Now, in the event that you want to perhaps add some other data sources that are available via the API, you can go ahead and click on Add New. And let's say the integration you want to request is not as popular as Fitbit and doesn't appear at the top. You can also use the search bar at the top to get exactly what you're looking for. And so, for example, if I wanted to add Chorus as an integration, I can go ahead and type that in here, and Chorus shows up for me to be able to add very easily. It's important to know that if there is also an integration that you're looking for that we don't currently support, there is also a form available at the bottom of the page, which allows you to request for the integration that you're looking for. Now, if you go ahead and fill out this form with the necessary fields, being the API documentation URL and some other optional fields, and click Requests, we will go ahead and build that integration out for you in the next couple of days. Now that I've gone ahead and chosen my sources, I can go ahead and configure what scopes I receive from Terra. Now, to do this, what we're going to go ahead and do is click on the Configure button above the Sources section. And a little modal should pop up that allows you to select and deselect the scopes that we have available from Terra. The idea of scopes is to categorize data into different categories so that you can select exactly what you need to make your app work. So, for example, we have the Activity scope, which gives you every single activity performed by the user in a normalized way. We have the body scope, which gives you a bit more information about how the user is doing in terms of body metrics and biometric data. And the rest follow intuitively as they are named. What you'll also see is at the bottom you have an option to enable and disable samples. Now, if you enable samples, what this essentially means, as you can see on the right hand side here, is you'll have access to more granular data, which essentially gives you specific data points at specific times. Now, in the event that you're developing an app where you want to have access to such specific data, you can go ahead and leave this on. Now that I'm done with my configuration, I can go ahead and click Save. And that's all done. Now that I've gone ahead and set up my sources, and I've set up my configuration, we're on to the next stage of the pipeline, the processes. This configuration essentially allows you as a developer to specify what processes you want applied to the data before it's sent to your destination. If you go ahead and click on the three dots here under the Processes section, you'll find a selection of three formats. Now, by default, we have the Terra standard selected, as this should suffice for most use cases. However, we do also offer the option of using the FIP file format or the FIRE format. Each of these formats enables interoperability in some way, shape, or form. So, for example, the FIP file was something that was coined by Garmin and enables interoperability between devices and platforms. And the same can be said about the FIRE format. And so if as a company you're interested in remote patient monitoring, you can go ahead and select the file format, which enables interoperability between healthcare devices and so on and so forth. Now again, in most use cases, and especially the use case I'm going to be demonstrating, the Terra standard should suffice, and so I can go ahead and actually close this because this is the default selection. Now that I've gone ahead and selected the Terra standard as the process we want to be applied to our data, like I said, for most use cases, this should suffice. We can move on over to the next and last stage of the flow, which is the destinations, which, as implied by the name, essentially allows you to configure where the data is sent once it's been processed. As you can see, we have no destinations added yet, and so if we want to go ahead and set that up, what we would do is click on the Add Destinations, and as you can see, we have a plethora of destination choices to pick from, and what each of these essentially represent is a different storage technology. Now, if you find yourself in a position where you don't already have something like a webhook set up on your server, and perhaps you use something like AWS S3, we cater to you and we allow you to actually receive data directly to your storage, as opposed to having to spend extra time developing to be able to receive data from Terra. And so, like I said, we have a plethora of choices to pick from. I'm going to go through each one and explain roughly how that works, but for the purposes of this tutorial, the demonstration will be using webhooks. So the first destination we have here on the list would be webhooks. And so if I go ahead and click on webhook and click on next, what you'll see here is a option to configure the destination webhook with a signing secret that will be used later on in the tutorial. And on the left hand side over here, we have a structure of how the payloads will be sent to your webhook. And so if I just expand on all of these, you can see that this is what the daily payload will look like roughly, the body payload, the sleep payload, and so on and so forth. And so this just really gives you an idea as to how the data is actually going to look when it arrives in your destination. And so this is the most simple one. And so to set this up, what you're going to need is a host URL. I'm going to demonstrate this with my own webhook server later on in the tutorial. And it's as simple as that to set up a webhook. The next destination we have on the list is AWS S3. And so if I go ahead and click on that and click on next, again, similar to webhooks, as we've seen already, we have a configuration on the right-hand side, and we also have a view of what the data is going to look like. So I'll start with the configuration. What you're going to need to use is an access key ID and this secret access key. Now, what this essentially means is if you have a IAM login for AWS, you would use the email associated with that account, or even just the name, either or, whichever one you have configured, and then you would use the password. I'm obviously not going to show mine, but that's what you would put in these two fields so that you can authenticate as either the root user or a specific IAM role. The next field you're going to have to fill in is what region you want to save data in S3 for. And so the default would be EU West 2, as this is what most people use. However, this could obviously be whatever you set it up to be. And the next and last field is the bucket name. You're going to have to make your own bucket on S3. And once you've done that, you can go ahead and come back and use the name of the bucket that you made. Now on the left-hand side, again, we have a brief overview of how this is going to look. We have the actual destination, which is AWS. And nested inside this, we have the name of the bucket that you make. And so, for example, if you don't name it Terra Payloads, but rather you name it Terra Data, this would just be Terra Data. This is just meant to mimic the default bucket name that we use here. And so if I expand that, as you can see, we have 3 more folders that will be made as each event happens. We have the 2022-03-16 folder, which is going to contain all of the data for each individual scope, as you can see here, where each file is stored as a JSON and has the user ID and the start time so that you can sort of aggregate that as you want. And the other folders are just for successful authentications and any re-authentications that may occur. The next destination we can pick from on the list is an SQL database. And so if I go ahead and click on SQL, click next. Again, the same as before, we have 2 panes, one being a configuration. And on the configuration pane, we have the first field, which is arguably one of the most important, which is how is your database stored? What sort of scheme does it use? By default, this would be Postgres, but you could also use something like MySQL or SQLite. And so the type of database that you're using would go here. The next field is the host. And this essentially is just the URL where your database is hosted. And so once you have that URL, you can just paste that in here. The next field in the configuration is the database field. And this essentially allows you to put in the name of the specific database where you want Terra to send data. And so by default, or as an example, we have Terra data, but you can name this whatever you want. And once you've decided a name, you can go ahead and put this in here. The next configuration option is the port. Now by default, this would be 5432. However, if you're running a database on a different port on your host, then you can go ahead and type that in here. And you can think of a port as just a numbered letterbox that acts on the host computer where the actual database is being run. And so for example, if the host is example.com on port 5432, you can effectively think of the host as a building name and the port as a door number. The last and final configuration you're going to need to put in here is the user configuration that Terra is going to use. And so in my case, I already have database credentials saved, and that's why it's being auto-filled here. However, if you want to use master credentials, that's also okay. Or as a developer, if you want to use your own credentials and you have read and write access, then you can go ahead and use that and put that in here too. On the left-hand side, the same as usual, you have your database, which would be the name here, Terra data in this case. And then you have one table for each type of payload. So for example, your users, your actual data payloads, and Terra other payloads. The next storage type that you can pick from is MongoDB, which is a very popular storage type. So again, if I go ahead and click on MongoDB and click on next, as you can see, same setup as before. And on the right hand side, we have the URL where your MongoDB database is stored, or hosted rather. You then have the cluster name, which is specific to MongoDB, but you can effectively think of this as the database name from the SQL option. And no surprise, we also need some authentication details. And so your username will suffice, and your password, again, like I said, this is auto-filling since I already have a MongoDB account. And on the left-hand side, similar to the database setup, you have your cluster. And within here, you have all different type of event types in different folders, with each payload being a JSON object. The next destination we have available, which we can pick from, is the Google Cloud Storage bucket. Now, this essentially is Google's equivalent of Amazon S3. And so on the right-hand side here, what you can see is a pretty short configuration. And the reason for this is because most of the configuration is contained in one file. But before we get onto that, we want to first put in the name of the bucket that we've made in our GCS. And once we have this name, we can put this in over here. And the next and final step is to upload a JSON certificate. Now, this essentially allows Terra as a third party to pass in data and store it on your GCS. And the way that you can acquire this JSON certificate is as follows. You'll want to first go ahead over to your Google Cloud Console. You'll want to navigate to I am an admin. Go over to service accounts. Once you're there, you want to click create service account. You may want to give it a name and description. So for example, you may want to name it Terra and Terra data, something to let you know that this is Terra. Essentially, this is the role for Terra to give you data. Grant it all the necessary roles. You want to give it storage object admin for full control over GCS objects. And so that essentially means that Terra won't have any issues trying to put data into your GCS bucket. You'll then want to create a service account key. And to do this, you're going to click on the newly created service account that you've just made. Go over to the Keys tab, click on Add Key, and choose Create New Key. You'll want to select JSON as the key type and click Create. The JSON key file will be automatically downloaded to your computer, and once you have this, you can go ahead and click on Upload File and put it all over here. The next destination type we have available is the AWS Simple Queue Service, or SQS. So if you go ahead and click on Next, once you've clicked on that, we'll see on the right-hand side here, we have a similar setup to Amazon S3. Reason being, this is obviously set up by Amazon, and so the configuration is pretty much similar. The only difference being that you're going to have to provide a queue name as opposed to a bucket name. Now at the top, we have the standard procedure from before for Amazon S3. We need a access ID, which essentially is either the username that you have set up for your IAM role or the email. And then you need your password, and you need to put that in over here. The next configuration will be the region. Again, like I said, the default would be EU West 2. However, if, for example, you have another region set up for your server, you can go ahead and type that in. And finally, we need the queue name. If perhaps you're developing a system that wants to process data sort of in real time and send this over to other microservices, then this may be a good option for you. Next type of data storage we have would be Cloud Firestore. Now, Cloud Firestore is essentially a no-code solution for MySQL or just SQL in general. And so this becomes a very good option for those who want to make a SQL database without having to have too much experience developing that. And so if we go ahead and click on Cloud Firestore and we click on Next, we see the setup for this is actually very easy. And the reason for this is because all Terra needs is a certificate. The process for that was described before. And so once you have this certificate, you can upload this here, and we will make the rest of the file structure for you, and the data will come in as shown on the left-hand side here. Very easy to set up. The next option we have on the list here would be Kafka. Now, Apache Kafka is a very popular distributed streaming service. And so if we go ahead and click on Kafka as an option and click on Next, what you'll see here is the relevant configuration information. Now, the first configuration is the broker host URL, and this effectively is just the public URL that Terra can use to be able to stream and send messages on the Terra topic. The next is the port that this Apache Kafka instance is running on. Now, by default, this would be 9092. However, if you're running it on a different port, you can go ahead and configure that here. Now, the next configuration is the topic name, and effectively, this is just the type of messages that you want to stream to Kafka to be sent and consumed. And by default, this would be Terra. However, if you want to name this whatever you want, you can go ahead and do so right in this box. And the last details are just the username and password, which will be used to authenticate Terra as authorized to stream messages. The next destination type we have here on the list would be Supabase. Now, Supabase is another example of a no-code solution that makes SQL databases very easy. And so if I go ahead and click on Supabase and click on Next, what you'll see here is actually misfilled information on my part. Now, as you can see here, as I've taken out the data, you can see the defaults. And so the host URL, similar to before, is just going to be the URL that hosts the database. Now, Supabase does this for you. As you can see here, we have a unique identifier followed by supabase.co. And like I said, this essentially is done by Supabase to make things super easy for you, so you don't have to go sniffing for URLs and you don't have to go ahead and host this anywhere. They do this for you. And so once you have this, you can put this in here. And the authentication process is just an API key. Now, the way to get this API key would be to navigate to your Supabase project, click on all projects, click on the project that is relevant to your app, click on settings on the bottom left. And in the settings, you'll see an API section. And in there, you'll see all your API keys that will grant access to your Supabase database. Now, at the bottom here, you have configuration for the bucket name or the database name. And so this will have to be made on your end. Unfortunately, Terra doesn't make this for you, but it's very simple. The process of doing this is as follows. On the left-hand side, you'll want to go over to database. And in database, you will see a list of your existing database tables. And on the right, you'll see a green button that says new table. You can go ahead and click on this and create your table. Once this has been done, you can go ahead and put this name into the field over here. And the next and final destination would be Azure Blob, which is still in beta, which means that you can essentially see some changes over time until this becomes fully released. But for the time being, I'll go ahead and show you how to set this up anyway. And so if you click on Azure Blob and click on Next, you'll see on the right-hand side here, this seems like a very simple authentication process or setup. And the reason for that is because we want to make this as easy for you as possible. And what we're going to need from you is a Blob SAS URL. Now, to be able to actually get this from your account, you want to go ahead and do the following. You want to navigate to your Azure portal, which essentially is just the login page. And once you've done that, you want to log in. You want to access your storage account, where the Blob is located. You want to find the specific Blob service within the storage account. Once you've done that, you want to locate the Blob container. And then you want to go ahead and generate the SAS token. And so to do this, you want to select the Blob or container, then click on the Generate SAS option, specify the permissions that you want to grant. You're going to need to specify read and write, and you want to go ahead and set an expiration date and time for this token. Now, you can go ahead and set this for as long as you want, but what's good to know is that the longer that you set this for, the longer that you can let this sit in the dashboard without having to change anything, because as soon as this expires, you're going to have to change this URL. Once you've chosen an expiration date, you can go ahead and choose any additional constraints, which is not necessary for this setup. And once you've gone ahead and done all of that, you can go ahead and click on the Generate SAS Token and URL. Once you have this URL, you're going to want to go ahead and paste this in here and click on Apply. The main reason why we have such a wide selection of destinations, which is ever growing, is because we want to make it as easy for you as a developer to connect your databases or your storage to Terra. And so this essentially means that as opposed to having to develop a webhook, for example, or maybe a specific type of storage destination to actually receive this data, you can go ahead and integrate exactly the storage that you have and receive data as quickly as possible. Before we can go ahead and set up this destination section, and in our case, set up a webhook, we need to actually go ahead and make our backend. And so that's what we're going to go ahead and do now. Once you've gone ahead and configured your dashboard, the next thing you want to do is set up your backend. And so what I'm going to do for you today is quickly just show you how you can use a library called Flask to quickly set up a web server, which we will then use as a destination in the dashboard. Now, the first thing you're going to need to do is make yourself a quick virtual environment. And the way you can do that is by running Python 3's native virtual environment manager. And so if you run this command, what you should see by the end of it, and once I hit enter, is you should see a folder pop up on the left-hand side called venv. And this just shows you that you've made the virtual environment correctly. Now, if you're on Unix or Mac OS like I am, then the way to enter into this virtual environment would be by typing in source, venv, bin, and activate. Now, the venv obviously would be replaced by whatever you named the virtual environment, and in my scenario, this would be venv. The way you know that this has worked is by seeing the venv tag on the left-hand side, and that's how you know that you have activated the correct virtual environment. Now we can go ahead and install our requirements, and the way I'm going to do this is by making a new file called requirements.txt, and in this file I'm just going to add in the Flask library, and to actually install it I'm going to go ahead and type pip install with the R argument and pass in the name of the file. Once this is done, you should see that all of this has been installed, and we can return back to our main backend.py file. The first thing we want to go ahead and do is just import a bunch of libraries. The first library we're going to import is logging, which is a native Python library, which is going to be used to display information going on in your server at any given moment, which will be later used to help debugging. This is also useful for when you want to contact customer support and you have an issue at hand. You're able to give the result of certain log statements, and that will help in the troubleshooting process. The next two import lines are for importing Flask and for importing a specific method in the Flask module called request. Now, the next thing we want to do is actually set our logging level. And what this essentially means is we're not going to see any low-level debugging events such as web requests. This is more so going to focus on the higher level events that you as a developer are going to program. But of course, this is up to you. You can obviously have this as debug, you can have this at warning, but for the purpose of this video and tutorial, I'm going to leave it at info. The next thing you're going to want to do is initialize a logger variable using the logger library that we imported from before, and give it an appropriate name with the getLogger method. Once we've done that, we then want to define our app as a variable in this Python file, and we can do that very easily by defining a new variable called app and using the Flask library with an appropriate name. I'm going to use dunder name dunder simply for formality's sake, and this essentially just means it's going to be named main. Now, once you've defined the Flask app that you will be using in this backend, you can then go ahead and start making a decorator for a route that we're going to be defining in this app. Now, once you've made your app, the next thing we want to do is actually make a route for our app. And this is going to be useful for when Terra wants to send you data and when you want to register your destination as a destination on the dashboard. The way we're going to do this in Python is by using a decorator, and we will use the app.route decorator function with the name of the endpoint that we want to use. So I will just use something like consume Terra Webhook, and we want to allow the methods post. Now what this essentially means is that this endpoint that we define will only accept the post method, and the reason why this is because Terra is always going to post data to you and is never going to get data from you. What we can then go ahead and do is define a new Python function called consume Terra Webhook. And in this function, we want to do a couple of things. The first thing we want to do is create a body variable and use the request object that we imported from before to be able to get the data from the request that Terra sends to you. And what you can then do is use the logger variable to display this in the terminal. Once you've done that, what you want to do as a developer is to make sure to return a status code. And in this case, we are going to respond with a 200 status. Now, the reason why this is so important is because if you don't do this, Terra is going to assume that your server hasn't correctly ingested the data, and so we're going to keep retrying, and we do this for about two days or so. And so that's the reason why you want to do this, is just so that Terra knows not to send the data again. Otherwise, you're going to have repeated data, and we don't want that. Now, so once that we've done that, once we finish making this endpoint, the last and final thing we want to do is really just a Python formality to be able to run our server, and we want to check if the name of the invocation for this script is of title main. And this essentially just means that rather than running the server when being imported as a separate file, the server should only run when you run Python and then the name of the file. That's all that really means. And so in this if clause, we would just want to do app.run, effectively running the run method on the app that you defined earlier, and this should run the server. And we can go ahead and test this by running Python and then the name of the file that we made. In my case, it would be Backend. And as you can see, the server is working in development mode. Now, the next thing you want to do is actually be able to turn this development server and expose it to the internet. And there's one way we can do this is by using a tool called Ngok. Now, to install Ngok, you're going to have to do the following. There are many ways to install Ngok. One of the most popular ways would be to use the macOS specific library manager called Brew. And so what I'm going to go ahead and do is just install that quickly. And as you can see, Ngok was successfully installed. Now, as you can see, the server that we're running is running on the port 5000 on our local host, i.e. on 127.0.0.1. Now, what we want to do is actually enable the internet to be able to access this. And so what we can do is take this URL, we will type in Ngok, HTTP, and the URL. And what you should see is the Ngok UI pop up with the forwarding URL that will point to your local server. This URL is going to become important in the next step. So go ahead and copy this link over. The next thing you're going to want to do is head over to the dashboard where we were looking at earlier, and you're going to want to set up a destination. So what you can do is click on the Add Destinations button over here. Select Webhook, click Next. On the left-hand side, you can see an example of what the data will look like when it's being sent to you. But what we're interested in is using this host field on the right-hand side. We can paste in our Ngok URL, as well as our endpoint that we defined. So this would be consume Terra Webhook, and we can click Apply. Now, once this has been done, the way you will know this has been successful is by changing over to your server And what you should see on your front end is a post request to this consume Terra webhook with the status code 200. This essentially means that the forwarding using Ngok was successful and Terra can successfully see your testing environment. You'll notice as well that as you've set up your webhook destination, you are also able to see a signing secret. The reason why this signing secret is so important and the reason why it's there in the first place is for you as a developer to be able to verify that the data being sent to you is from Terra. So what you want to go ahead and do is copy this over to your server. The next thing we're going to want to do is install the Terra Python wrapper, which will be useful when it comes to authentication of your users and for retrieval of data. And so what you can go ahead and do is head on over to your requirements file, and just below the Flask dependency that we defined earlier, you can add terra-python. If we go ahead and in a new shell, run the same command from before, you should now see that Terra Python has been installed. So if we head back over to our backend.py, we can now start using the Terra library to start making some requests. So the first thing we want to do is just import that into our server. From terra.base client, import Terra. The next thing we want to do is get our credentials from the dashboard and retrieve our credentials. And once that's been done, we have that in our code like such, and this will be used for making requests as ourselves. The next thing you want to do is initialize a Terra object, and so I'm just going to name this variable Terra. I'm going to use the Terra object blueprint that we imported earlier. I'm going to define the API key as API key, like mentioned above. I'm going to pass in a dev ID, and I'm going to pass in the dev ID that we got from the dashboard earlier, and I'm going to pass in a secret that we defined earlier, again from the dashboard. And so once we have this object, we are then able to perform all the Terra-related functions as a developer. The next thing you're going to want to do is use the webhook secret to be able to verify that the payloads are indeed from Terra. To do this, you're going to want to declare a new variable called verified, which is going to store a Boolean value. And this verified variable is going to be the result of the check Terra signature method on the Terra object that we declared before. The first parameter will be a UTF-8 decoded version of the body sent in the payload. And the second will be the Terra signature that we send as a header along with the payload. As you can see, we have here a check to see that the verified Boolean is true. And if it isn't, then we respond a 403 unauthorized error, as you would expect. Otherwise, we carry on as normal, and we will respond with a 200. So if we want to go ahead and test this, we can head on over to the generator. We can generate some data for whichever provider you'd like. And once you're done, you can click Send to Destination. Once this is done, you should see that in your running server, we have indeed received the payload, and the reason why we know it's Terra is because it hasn't failed, and it's logged this statement here, which it would only log if the payload was verified. The next thing you're going to want to do is head on back to the dashboard, click on the Add Destinations, and as explained before, to set this up, we're just going to click on Webhook, click on Next. Now with the copied URL that we took from the terminal, the Ngok URL more specifically, we can go ahead and paste that here for the host URL, remove the trailing white space, and we're going to want to add the specific endpoint name that consumes the Terra payloads. So if we go ahead and copy that over, which should be consume Terra webhook, and add that to the end, we click apply. As you can see, that's all worked successfully. Again, whilst we're here, we may as well take another stop on the dashboard. And the next place you're going to want to check out is under the AI tools and the widget section. Now this essentially allows you to go ahead and configure what the user sees when they authenticate their device. Now, as you can see, we have a little preview here that shows what it would look like on a phone. Naturally, we have Fitbit showing up here since that's the only provider we have enabled. And you can go ahead and change the color of this. For example, if you have a blue themed app, you could go ahead and change this to the background of blue. Perhaps you want the provider box to be a slight gray. You could do that as well. And perhaps you want the text to stay the same and the rest to stay the same. Once we've gone ahead and changed this to be the color that we want, we can click on save. It will tell you that it's been updated, and you can go ahead and preview what this would look like for an end user. Now we want to authenticate our first user. And the way we want to do that is by making a new endpoint on our backend. And so we can use the app.route decorator that we used before with the Authenticate name. We want to allow the methods get on this request, and we will just call the function Authenticate. And in here, we want to use the Terra object that we instantiated before, and we want to use the generate widget session method. And what this is going to do when we pass in everything is this is going to communicate with the Terra API using our credentials, and it's going to give back a widget session URL that we can then use as an end user to authenticate our device. And so the thing that we're going to need in here is we're going to need a parameter for a list of providers. By default, if you don't provide anything, it will just default to what you have on the dashboard. But for the purposes of this tutorial, I'm going to specify them myself. I'm just going to specify Fitbit. And the next parameter that we want to give in is a reference ID. And this just essentially is a way for us as developers to consolidate references to consolidate users that Terra is storing and how that relates to the users we have stored on our app. And so in this case, I'm just going to use the ID 1234. And we want to get this as a JSON so that we can have this as a dictionary, as a valid response from this endpoint. So if we want to go ahead and restart our server, and we navigate to our browser, if we go ahead and open a new tab, and we use the Ngok URL from before, appended with the name of the endpoint, which in this case is Authenticate, what you should see is a valid response. As you can see, there is an expires in, which is essentially the amount of seconds that this that this widget session is alive for. But most importantly, we have a URL. We have a URL field with the URL of the widget. So this isn't very user friendly. So what we can go ahead and do is go back to our endpoint. Now the way that we can make this more user friendly is by returning a button as opposed to a raw URL response. And so what we can do is we can take the widget response we got from Terra, extract the URL field to get the URL for the widget, and we can return a Flask response which corresponds to a button with the widget URL embedded into the button when clicked. And so once we've done this, we can go ahead and restart our server. And if we head on over back to our browser and we refresh, we should see a button here that says Authenticate with Fitbit. Now, if we go ahead and click this, we'll be redirected to the Terra widget where we can go ahead and log in with our user. I'm going to go ahead and log in with my account. And as you can see, we have successfully authenticated to Fitbit device through Terra to our app. Now we can go ahead and close this, and we can verify and make sure this has happened by checking our server. And as you can see, we have received a user authenticated event, and this is how we know that this has been successful. Since we've gone ahead and authenticated our first Fitbit user, we can also go ahead and use the debug tools that we have available on the dashboard to double check that this has gone through successfully. Now the way to find the debug tools is just to look here on the left hand side, and you'll find it quite intuitively under tools. And it would be under the debug section. And so here, as you can see, we have a bunch of payloads that relate to the user we just authenticated. We have the auth success. And as you can see, this was successfully delivered to our webhook. It was for the provider Fitbit. It was of type webhook. It was of type auth success. And it was at this time for this user ID. And so this is really how we can know as a developer that as we've authenticated a user, it's worked successfully and everything to do with the communications between Terra and our server has been successful. We have two other panes in the debugging tools. We have the users section, which will show us our users. As you can see here, we have the Fitbit device that we authenticated earlier with the reference ID that we used. And we also have the time that it was connected. And so this is essentially how we know that this user has been authenticated to our service. And last but not least, we have the chart section, which essentially just gives us some rough data as to how many of the payloads that are being sent from Terra to us are successful and failures. And so as you can see here, we have a graph to show the successful payload deliveries compared to the failed payload deliveries. And as you can see, everything here seems to be running smoothly, as the only graph we can see, or the only line we can see, are successful payload deliveries, and there are no failed payload deliveries. We also have some more data just down here that sort of goes into detail as to how long it took for our data to accept the data. And if our server is running slow, you can also see that over here to see how many slow responses we have as a frequency table, and also a pie chart to see sort of the breakdown of response times. Now, the most important thing we need to do is take note of this user ID, and this is a user ID generated by Terra. So if we just copy this, we can actually leave this as a comment for now as we're testing. And so this is going to be the user ID we use when we want to query and pull data. Now, by default, Terra is going to send data to this webhook, as we demonstrated earlier. However, now what I'm going to do is show you how you can extract data or historical data using the API. And so again, what we can do is actually just make a new route like before, and we can name it something to the extent of backfill. We will specify the methods to be a list with get, as this is a get request we want to do. And we will define a function named backfill. What we can do in this new backfill method that we've just started making is we can store this user ID in a variable. We can then use the Terra object to define a new variable. With the from user ID method, we can then pass in the user ID that we defined earlier, and this should now be an object that we can then perform some queries on. So we wanted to get some sleep data, so what I'm going to do is just use the built-in getSleep method. And this method takes in a couple parameters. It takes in a start date and an end date, a toWebhook Boolean parameter, and a withSamples Boolean parameter. Now, I know exactly what data I want to query, and I know when it's from. So what I can do is define a start date variable and use the datetime library, which actually we're going to have to go ahead and import at the top of our server. Now, if we go back down and we use the datetime module that we just imported, which is native to Python, and we pass in the year and month and day. For me, this would be 2023, August the 11th, in this order. And we pass in an end date of the same +1. We pass in toWebhook as true, and we pass in samples as true, since we want to get some sampled data. Don't forget to store this in an appropriately named variable, such as sleep data. And once you've done this, we can just return the JSON format of this response. And if we go ahead and restart our server, and we remember this endpoint, if we head on over back to our web app, or our supposed web app. And we take the Ngok URL from before. What you will see is that it takes a little bit to load. And as you can see, the data has been sent to the webhook. Now, if we go back on over to our server, now I'm going to show this in the browser, as sending it to the server is not very easy to read. So if I just change this to webhook to be false so that we can get it in the browser, and we restart our server, we refresh the page, what we should now see is the data from my Fitbit on the browser. And as you can see, we have our heart rate. And if we scroll down, further down, what you will also see is some other very important information, such as my average heart rate, the start time that I slept, and all the other useful information, which you can also find more details on in the documentation. But this is just an example of how you can use the API and the webhook system to receive new data for the users you've authenticated. Now that we've highlighted how we can use the unified API and integrate this into our backend, we now want to go ahead and develop our mobile app. Before we go ahead and do this, we're going to need to make one change on the dashboard. If you remember from the configuration before, we were talking about the tags that appear alongside the providers. As you'll see when you click on the Add New button and you see Apple Health on top, you'll see that there is an SDK only tag. And this is for a reason. This makes it obvious to you as a developer that this is only available via the SDK. And so now that we're actually going to go ahead and develop our mobile app, we can go ahead and click this and click Save. And so now we have two sources of data. Now that we've gone ahead and done this, we can go ahead and set up our authentication tokens, which is the next step. Now, before we move on over to making our mobile app, which we'll be using to extract heart rate data from Apple Health, we first need to do one more thing on our backend to make this possible. What we need to do is define one more endpoint, which we'll do again, like before, the same way we've done it already. We'll name this Auth Token. We will allow the methods get. We'll define it as Auth Token. And in here, what we're going to do is we're going to make one more request to Terra servers. What we need to do is, using our existing credentials on the backend, we need to request a temporary authentication token, since we don't want to store our API key on the mobile app. And what this essentially means is that every time the mobile app wants to authenticate a new user, we have to first get an authentication token from the backend, which it lasts for 180 seconds, to be able to then authenticate that user. Now, this is useful if you want to authenticate users from the API on your mobile app. Since we're only going to authenticate Apple Health, which is not available via the API, this isn't strictly necessary. The only reason why I'm doing this is because if you do, for whatever reason, want to authenticate Fitbit users, Garmin users, or really any providers that are available through the API, you're going to have to do this step first. And so, first thing we want to do is actually just import the requests library up at the top here. The next thing we want to do is define a new variable, which will store the URL of the endpoint. I have this copied over here already, and so I'm just going to bring this over. The next thing we're going to want to do is use the requests library to make a request. But before we can do that, we need to define some headers. And the first header we're going to define is an accept header, which essentially just means that we accept JSON responses. And the second and most important header will be the XAPI key header. Now, we already have this defined in our backend, and so what we can do is just use the API key that we've stored already. Now that we've defined the headers, what we can do is use the request library that we imported earlier, make a post request to the URL we defined just now, and we can pass in the headers that we defined just now. And once this is done, and once we've done this, We can store this in a variable. We can store this as a variable called token response. And with token response, we can return token response.text. We also need to include our dev ID so that Terra knows who we are identifying ourselves as. And once we include this in our requests, we restart the server and we head on over back to our web app and we refresh with this endpoint that we defined earlier. What you'll see is we have a response that is successful, that indicates success, and we have our token that we can use on our mobile app to authenticate new users. Now it's time to make our mobile application. For the purposes of this tutorial, I'm going to be using React Native, and the following is how you initialize a React Native app. You're going to need the Node Package Manager software, which comes installed with Node. Now, once you've run this command, the next thing you need to do is go ahead and type in this command. And this command essentially just uses the package we've just installed to actually initialize the React project. And I'm just going to name it my app. We can then decide whether we want to just make a new app or whether we want to use a template. I'm going to go ahead and just use a default new app. The next thing you want to do is, as it suggests here, go ahead and change into the iOS directory within your new app that you've just made and run npx pod install. Click yes, or type in Y. And once this installation is done, to make sure that everything is working, what you can go ahead and do is change back into your root directory for your app that you've just made and run npm start, and this should work. As you can see, there's no errors, everything's working fine, and so what I'm going to do is just Control C to stop the app running, or stop the server running, sorry. The next thing you're going to want to do after you've done all of this is you're going to want to navigate over to your app.js file and leave that open, and in your command line at the root level of the app, you want to go ahead and install the Terra React package using npm. Once you've typed that in, go ahead and run, and give that a second to run and install. And once that's done, you want to go ahead and import the important functions from the Terra React app. This is taken from the docs, which has a very nice written guide on how to use Terra React. And so this is that line. And essentially what we're doing here is we're importing the initialize Terra function, the initialize connection function, the connections enum, and the get user ID function. Now, the purpose of all of these, the initialize Terra function is essentially just what you're going to need to run as soon as you've run the app. The init connection is what you're going to want to run when you want to first initialize a connection to Apple Health or Samsung Health, whichever you prefer. In this case, we're using Apple Health. The connections enum is what you want to use to specify what connection you want to connect with, and so the connection enum will be passed into the init connection function. And the get user ID will be what you use once you've done the authentication and you want to then get data for that user. And so that's all the important functions imported. We've already gone ahead and run the pod install function in the iOS directory, so I shouldn't be doing that again. But if you haven't already done that, then please make sure to do so. And once you're done, make sure to go back to the root directory. There is one more thing that we need to do in order to be able to develop for the iPhone and to enable seamless data fetching from Apple Health. What we need to do is go ahead. We need to add HealthKit as a capability to our app. And so what this essentially means is that we're declaring from the get-go that our app wants the permission to be able to access data from HealthKit, and so the user knows and can agree to it. And the way to do this is to navigate over to the iOS folder and open this folder in Xcode. If you don't already have Xcode, you're going to need to install Xcode, and once you've done so, you can return back to this point in the video and continue with opening this folder in Xcode. Once you've gone ahead and opened this in Xcode, what you then want to do is click on the main app icon with the App Store logo. Go over to the info subbar, and you want to add a key here. Feel free to hover over any of the existing keys and click the add button. you want to go ahead and scroll down to the privacy section. And once you're in this section, you will find the health options, and you want to select health records usage description and paste yes. And you want to add one more under the same section, but instead of the one we've just added already, you want to add the health share usage description. You want to add both of these and make sure that that's updated. Once you've done that, in order to enable background delivery, which essentially just means getting data from the health app in the background, whilst your app is running in the background and not in the foreground, what you want to go ahead and do is add a new key entry, navigate down to P. You want to add the permitted background tasks scheduler identifiers. And here what you're going to want to add this URL, which essentially is just allowing the app to make post requests to Terra. You're going to want to add this, and this will be on screen for those of you who maybe can't make out exactly what I've typed here. But once you've added that in, you can just click enter, and that should be fine. You can go ahead and collapse that now. And once that's done, you need to navigate over to signing and capabilities, click add capability, type in health kit, and you should now be able to add that. And you want to make sure that you also click background delivery checked and clinical health records checked. Once this is done, you've done everything you need to do to be able to enable getting data from HealthKit. Once that's done, once you've done this, you want to head on over back to your app directory. You want to navigate to iOS and then the name of your app and open app delegate. Now in here, what you want to do is you want to import the Terra iOS Swift package so that we can actually interact with Apple Health. And we want to add this line of code, which will set up the background delivery and finalize that in the app. Now, once we've done all this, we can head on over back to our app. And so now that we've gone ahead and set up all the permissions required by the SDK and your app, the next steps are to use the Terra SDK to retrieve the data. As you can see on the right hand side here, I've also got the simulator running, which I will use to show that I do indeed have some data in Apple Health, albeit very small, but it is indeed there for the 29th of February. And so this is the data that I'm going to try to extract. And so to do all of this, I'm going to make a new function, and I'm going to call it initialize and get body. I'm going to make this an asynchronous function. And in this function, I'm going to first of all initialize the Terra data client. I'm going to initialize the Terra client by using the init Terra function that we imported earlier. And in here, I'm going to use the dev ID, and I'm going to give in a reference ID of 12345. However, this could be whatever you want. This could be a UUID. This could be the phone's hardware ID. It's really up to you. Once this is done, I'm going to go ahead and console log this init to make sure that everything's running correctly. And later on in the development, we can see exactly what's gone wrong if anything does go wrong. Then what I'm going to go ahead and do, I'm going to use the endpoint that I made earlier in the tutorial to get an authentication token. So I'm going to use the fetch library. I'm going to go ahead and copy and paste the endpoint. This would be the Ngok URL appended with the endpoint that you named. After this, what we're going to go ahead and do is add a then clause. And in here, we're just going to say that the response is then mapped to the JSON of the response. Once this is done, we can then add another then clause for the response, for the output of this, for the output of this. We can define another asynchronous function, which takes in data as a parameter. And in the function body, I'm going to say let the auth token equal to the data that we received in the response dot token. So in other words, we're taking the response from our backend and we're taking the token field and assigning that to auth token. And in order to make sure that we have everything working, I'm just going to do another console log, and I recommend that you do this too so that you can see exactly what's going on. I'm going to use the funny looking quotation marks along with the $ notation to be able to insert the auth token. I'm just going to type in auth token so that when this happens we can see what the auth token is. And once we have this auth token, the next thing we want to do is we want to initialize a new connection. And so I'm going to initialize a variable called connection, and I'm going to await the response from the init connection function which we imported above. And in here what we want to do is we want to specify what connection type we want to use. Now I've already gone ahead and done so at the top of my app, and I've defined connection type to be from the connections enum, the Apple Health option, since we're developing on iOS and we want to get Apple Health data. Now of course, if you wanted to, you could just directly use the Apple Health enum option and pass that into the init connection function. However, for the sake of simplicity and consistency, I would recommend using a variable that you define at the top. The next thing we want to pass in is our auth token, which we just retrieved from our backend. And the next parameter that we need to pass in is a Boolean variable to decide whether we want this to be running in the background and sending data to our webhook. For the sake of this, we don't need to, since I'm just going to extract the data once. But of course, if you want this to run in the background and send data to our backend and then to your backend consistently, then you would pass in true. But I'm going to pass in false. What I want to do is console log this just to make sure everything is working properly. And I'm just going to print connection.success to see if it's worked. And I'm just going to name this connection status. After this, once we've initialized the connection, we want to get the user ID. And so what we're going to do is we're just going to define a variable called user ID and use the get user ID function that we imported from the SDK. And in here we want to pass in the connection type. Again, in this scenario, this would be Apple Health. However, you could obviously just pass this in using the connections enum. Now, once we've done this, what we want to do below that is just console log this so we can see what's going on. And this will make it a lot easier to determine where the problems are. And so I'm going to take my user ID variable and I'm going to print out the user ID parameter, and so that should be fine. Now the next thing I want to do is the most important part, and that is to actually retrieve the data. And so what I'm going to do is I'm going to define a variable called data, and I'm going to await the response from the getDaily function, and I've already imported this at the top. If you haven't already, you should make sure to comma separate all of the imports from the SDK and if you wanted to import the getter function for whatever data type you're looking for. So this could be nutrition, for example. This could be the body scope, for example. This could also be the body scope, and so on. But I'm going to use the daily scope for this tutorial. And so at the bottom here, like I said, I'm going to await the getDaily function, and in here I'm going to pass in the connection type, which in this case would be Apple Health. I'm going to pass in exactly what date I want to get the data for. Now, like I was showing you in the beginning of this video, and as you can see on screen, the data that we have stored is for the 29th of February. So what I'm going to go ahead and do is create a new date object for the 29th of February. And as an end date, I'm going to pass in the 1st of March. As you can see. And the last thing we want to do is make sure that this does not get sent to our webhook, but we can obviously do that as well if you wanted to get sent to your webhook as opposed to the app itself. And so I'm just going to pass in false here. And once this is done, what we can do is we can take this data variable and we can print, or we can console log the data field of the data object that is going to get returned. And at the bottom we need to add a callback function which will act if there is any errors, to make sure that everything is safe. And so we're going to take this error and we're going to pass it into a function, and we're going to log this as an error. Error getting data, and pass in the error as well. And so now once this is done, we've essentially made our function that will do everything for us. And so with that being said, we've essentially created the most important function of the app. We've made a function to initialize the connection to Apple Health, and we've made the function actually retrieve the data for the dates that we're looking for. And so there's one last thing that we need to do, and that would be to go to your main app component. And in here, we just want to define a use effect with a callback of, and in the callback, we want to call the function we just made earlier. And as dependencies, we want to set nothing, which essentially means that on app loading, or if anything changes, any event that happens, this function will be run. And for the purposes of this video, this basically means that when I open the app, everything is going to get run for me. I don't have to worry about calling it from the app. So now if I go ahead and run npm run iOS in my terminal, what we should see on our phone and in the console is not only the data being logged and all of these console logs being shown, but you should also see the app open up. Now, obviously, we haven't designed any app, so you're not going to see a pretty front end, but what you should see is the app download to the phone. So if I go ahead and run this, as you can see on the phone, we are bundling up the app, and the app is not showing anything because we haven't designed anything. But as you can see over here, and I've noticed here that I've made a slight mistake in my code. This should actually just be the field token. This shouldn't be auth token. And so if I go ahead and run that again, as you can see, we have successfully initialized the connection. We have an auth token. And on the phone screen, as you can see, this is as expected. This is essentially the app asking the user for permission to share their data. And so for the purpose of this video, I'm just going to go ahead and click all and click allow. And once this is done, as you can see, the connection status is true. And so all these logs are showing that everything has gone through successfully. And at the bottom, you can see that there is a data object. Now, we're interested in seeing that specific data point of 67 BPM for the heart rate on the 29th. And so what we can actually do is we can, down here, we can also console log the specific field that has this data. And in this case, this would be the heart rate data over here. And so if I just copy this and put this over here, what we'll then see is that this all runs again. And as you can see, when I print out the first object in this list of data that we get back from the daily payload, from the daily getter, we can see that the average heart rate of 67, which would be the average as there's only one data point, is showing with a min of 67 and a max of 67. I'm also now going to show you what this would look like if we want to send this to our webhook. And so this essentially would be how this would work if you wanted to get sent to your server as opposed to the mobile app directly. And this would be the process that you would follow if you wanted to send this data to your webhook as well to process in the backend. And so if we actually go ahead and check, we can see indeed that data has been sent with our data that we expect with a minimum HR of 67. And so now that we have this data, we can do exactly what we want with it. If we wanted to recommend activities based on your current heart rate, and then we wanted to determine whether the activity was good for you by looking at your HRV and average heart rate throughout the activity, we could do that using this data.